geometric sequence is different than an arithmetic sequence because we're going to be multiplying or dividing to find the next term. So, you multiply or you divide to find the next term. Now, for example, let's say we have 3, 6, 12, 24, 48, etc., etc., etc. Now, we're still going to get a sub 1. That's going to be your first term. And in this case, it's a 3. You're still going to get a d, or d was used for distance. We're going to use r, and this is going to be called the common ratio. And in order to figure this out, r is going to be equal to, for example, a sub 2 over a sub 1, or generally speaking, a sub n plus 1 over a sub n. So it's, for example, it might be term 4 divided by term 3. Now, for example, a sub 2 is equal to 6, a sub 1 is equal to 3, a sub 2 divided by a sub 1 is equal to 6 over 3, which is equal to 2. This is the common ratio. Now, this one was easy because we're multiplying everything by 2. But not necessarily your geometric sequences are always going to be as easy as you want them to be. For example, if you have 4 8/3, 16 ninths, 32 over 27, 64 over 81, what is r? Now, there's a couple different ways that you can do this. You can take a2 divided by a1, 8 over 3 divided by 4. Use a complex fraction, which means 8 over 3 divided by 4, which is really 8 over 3 times 1 over 4. 4 divides into 8 2 times. You're going to get 8 over 3 times 4. That's a 2. 2/3. That's your common ratio. So you can figure out your common ratio that way and get 2/3, because if you take, for example, 4, multiply it by 2/3, you're going to get 8/3. So you have 4, comma, 8/3. Then you take 8/3 times 2/3, 16 over 9. There's 16 over 9. That's our next term. Then you take 16 over 9 times 2/3. That's going to be 32 over 27. There's your 32 over 27. 64 over 81, etc., etc., etc. Now, a sub 2 was times r. A sub 3, a sub 2 is equal to a sub 1 times r. A sub 3 is equal to a sub 2 times r, which is a sub 1 times r times r. Because a sub 2 is equal to that, which is equal to a sub 1 times r squared. So that's a sub 3. Now n is 3. What's the power? How can you use n equals 3 to figure out the power of 2? Let's take a look at a sub 4. That's a sub 3 times r, which is equal to a sub 2 times r times r, because a sub 3 is a sub 2 times r, a sub 2 is a sub 1 times r, so this is a sub 1 times r times that r times that r. So this is really a sub 1 times r cubed. That's a sub 4. So when n equals 4, my power here is 3. So how do I go from 4 to 3? That's the big question. How do I go from n equals 3 to a power of 2? Well, that would be 3 minus 1. Sorry, 3 minus 1. This one's 4 minus 1. So if I want to find, for example, if I want to find a sub 4, I need a sub 1 times r to the third power. If I wanted to find a sub 10, use some logic. If a sub 3 is equal to a sub 1 times r squared, and a sub 2 is equal to a sub 1 times r, what do you think a sub 10 is going to be? Give you a pause here. So pause it, try to think of it. It ends up being a sub 1 times r to the 9th. So a sub n is equal to a sub 1 times r to the n minus 1. And that's the lovely formula that we're going to use for this. So that's your geometric sequence. Those are the big things we need to be able to do from it. And hopefully everything will go nice and smooth.